So we are going to start the next chapter, that is nitric acid. Now, nitric acid, it was initially called as, what you can say, heavy water, or you can say it was also called as strong water. Nitric acid. It was called long back by the alchemist. Alright, alchemist, we can say that. Long back it was called as strong water or heavy water or whatever you can say that. Why? Because it has got a corrosive reaction on metals. Alright, it has got a corrosive reaction. Metals when react with this nitric acid, it gets corroded. You know what's corroded? Means the surface of the metals develops a layer of oxide over it. Like rusting is a corrosion process. What is rust? Rust is nothing but hydrated ferric oxide. Fe2O3 dots XH2. It is a corrosion. The process is corrosion, isn't it? So in this way, the metal gets corroded. Now, the metal does not get rusted. No. It is not I am saying the metal is getting rusted. Rusting is a different thing, and here when it reacts with nitric acid, the metals is a different thing. Don't get confused. Just I explained you by giving an example to make you understand the meaning of the word corrosion. Alright? Yes, that's it. Now, after that, Glauber was one of the scientists. He prepared nitric acid. Alright, he prepared nitric acid by heating concentrated sulfuric acid over niter. Niter means potassium nitrate, KNO3. Alright, when Glauber heated nitric acid, what you can say, niter with concentrated sulfuric acid, KNO3 with H2SO4 comp, he got nitric acid. He only, what you can say, gave the name as nitric acid. He only gave us the name nitric acid. Who? Glauber, G-L-A-U-B-E-R. After that, Cavendish. He gave us the composition of nitric acid. The nitric acid consists of, what is that? What is the formula of nitric acid? HNO3. He only gave us the composition. The nitric acid consists of hydrogen, nitrogen and oxygen in the ratio of 1:1:3. In the ratio of 1:1:3. Hydrogen, nitrogen and oxygen. He only gave us. Who? That is nothing but Cavendish. Clear? In this way, this is the, what you can say, the history of nitric acid. It goes. Now, nitric acid is present in the air in the form of, what you can say, free state. It is also presented in the form of combined state. In the combined state, it is being present basically in the form of nitrates. Like we are having, that is KNO3, niter, which we call it as NITRE, niter, KNO3, potassium nitrate, which is also called as nothing but Bengal saltpetre. Bengal saltpetre. Similarly, NaNO3, which is also called as child saltpetre, PETRE, we can say that. You must be knowing this terms or the formulas or the names, we can say, you might have read it somewhere in the lower classes. So in this way, we are having potassium nitrate, we are having sodium nitrate like niter, or what you can say, child saltpetre. We are also having, that is nothing but ammonium nitrate, or we are also having calcium nitrate, and so many other compounds we are having, but we don't have any other name for it. A special name we don't have for it. So in this way, it is present in the combined state in the form of salt. It is being present because combined, I am saying. Now in the free state, nitric acid, it is being present in the air, and it is being present in the, and it is being formed by the help of nitrogen fixation process. We can say that nitric acid is being formed. Now what is that? See, nitrogen reacts with oxygen in the presence of lightning discharge. Lightning discharge means at a very high temperature. I told you earlier also this particular one in the ammonia. That is, under lightning discharge means the temperature is around 3000 to 4000 degrees centigrade, or more than that also. What it forms? It forms NO, nitric oxide, a colorless, odorless gas, we can say that, NO. Now, nitric oxide further combines with oxygen to form, that is NO2, 2NO plus O2 gives 2NO2, a reddish brown colored gas, nitrogen dioxide. Alright, now nitrogen dioxide further combines with oxygen which is present in the air and water or the moisture which is present in the air to give nitric acid, HNO3, we can say that. You can balance it as 2HNO3, we can say. So that is nothing but, here we can write it as 2NO2 or 4NO2, we can balance it this one later on. So in this way, what you find is that we will see we are getting, that is nitric acid, we can say that. Clear? That is, we can say. Now, if I put it here 2, it will be 2 nitrogen, so it will be 2 nitrogen here, but oxygen will be how much? 2 to 4, and here it is 1, 5, we can say that. 2NO2, say 4, 4 to 6, 1, 7. So in this way you balance it, this particular one. You know how to balance it. So in this way we got nitric acid. Now calcium carbonate or limestone, which is being present in the soil, reacts with nitric acid to form calcium nitrate, CaNO3 whole twice, plus carbonic acid it forms. It's a double decomposition reaction to HNO3. It's a double decomposition reaction. See, H2CO3 is being formed. Plus minus, plus minus. I am writing the charge, not the balancing. Mind it. Alright, so in this way it forms carbonic acid. But carbonic acid is unstable, you know that. It decomposes to give you water and carbon dioxide. In this way, what you get it? You get, that is nitric acid in the air. It is being present in this particular way. It is being formed by the nitrogen fixation process. Alright. Now, next is how nitric acid we are preparing in the lab. How do we prepare in the lab? Already I said you, Glover what he did? He prepared nitric acid. Glover prepared nitric acid. From where he prepared? He prepared it from niter, that is potassium nitrate, and he used concentrated sulfuric acid. The same phenomena or the same process we use it here also. The same phenomena or the same process we use it here also. What we do is that we take a retort, this sort of, a shape is this sort of, retort, a glass apparatus, we can say that in this way, a glass apparatus. This is known as a retort. Clear? This is a retort here. Now what we do is that we add here potassium nitrate, which is a solid reactant, KNO3. Got it? And what we do is that we add H2SO4 conc and we heat it from below. This we are heating it from below. Clear? Now in the retort we have taken it, concentrated sulfuric acid and potassium nitrate we have taken it in the retort. This is completely made up of glass, this particular one. Let me make it a little bit better. This is completely made up of glass. We are having an opening. Through this opening we are adding it. Fine. Now next is what we have done. We have taken that is a round bottom flask and we have kept it in an inverted position, tilted position in this way. We have taken a round bottom flask and we have kept it in a tilted position. In this way we have kept it in a tilted position. We have taken a round bottom flask. Now here that is cold water is being allowed to fall over this round bottom flask. Cold water. Alright, a tap of cold water is coming and continuously it is falling over it. Or you can do one thing, you can keep this particular one in a freezing mixture. You can give this one. Because I want low temperature. The main concept is that I want a low temperature. So the cold water, it will cool the gas which is going to come here and the gas is going to condense here. If I keep it in a freezing mixture, same thing is going to happen. Clear? Now, next is here, what is going to happen? Let us see the reaction. KNO3, when it is heated with H2SO4 conc, in presence of H2SO4 conc, you can see concentrated sulfuric acid, and the temperature should be below 200 degrees centigrade. What it's forming? KHSO4 and HNO3, nitric acid, you can see that. See, KHSO4 and HNO3 it being forms. It is being formed below 200 degrees centigrade. You know why it is below 200? Because otherwise potassium sulfate is being formed here. And you have studied in hydrochloric acid, in hydrogen chloride chapter, that if potassium sulfate is being formed, it's sticky substance. It will stick to the glass apparatus and it cannot be removed by any method. Moreover, it's a wastage of energy. Because the reaction which is carrying, which can be carried out below 200, above 200 means it's a wastage of energy. And the third thing is that at a high temperature, nitric acid will decompose. It is going to decompose nitric acid. For all these reasons, what you find is that we keep it below 200 degrees centigrade and we heat it. Now instead of potassium nitrate, that is niter, you can also take sodium nitrate, NaNO3. You will be getting here NaHSO4, that's it. But nitric acid will be getting it. Okay, so this reaction. So here of course what we do is that we don't put any cork or any other thing. Why? You can see that entire apparatus is made up of glass. Nowhere I have used cork or rubber or anything. Do you know why? Because nitric acid, what I said you in the beginning, all chemists what it said, that it is strong water. Alright, why? Because it was highly corrosive. So here also same thing. If you take cork or rubber or anything here, the nitric acid vapors, because vapors are coming now, from here vapors are coming. Nitric acid vapors, because when you are going to heat, the vapors are going to come from here. So nitric acid vapors will react with this cork or the rubber and it will degrade it. It is going to get degraded. Or it's going to react with it. Alright, so for that particular reason, to prevent it, we are not using any cork, rubber, anything here. Alright, we are directly passing the gas, the nitric acid vapors, not the gas, sorry, the nitric acid vapors, we are directly passing into this particular flask, where the liquid, that is nitric acid, here the liquid HNO3 is being collected. Clear? Nitric acid in the liquid state, it is being collected here. Because what I said, we are putting here, we are supplying cold water from here. So what are the vapors comes here, it gets condensed. It gets condensed here, the vapors get condensed here and it forms a liquid. What is liquid? Nitric acid. That is liquid it being formed. Clear now? So why we are not using this particular one? The next is that, why sulfuric acid is prepared? Why not HCl? Suppose if I take HCl, then what will happen? KCl plus HNO3. Definitely. Nitric acid is being formed? No. Theoretically it is being formed. Practically it is not being formed. If you take here HCl. Theoretically you can say that sir, it is going to form KCl and HNO3. You can write it and see it is forming. But theoretically, practically it's not being formed. Why? Because nitric acid is a volatile acid, and HCl if I take, it is also a volatile acid. One volatile acid cannot replace another volatile acid. You have studied in acid basis salt chapter this one. One volatile acid cannot replace another volatile acid. Definitely, you apply your concept here. Volatile means it is going to vaporize easily at low temperature. So if it will vaporize easily, will it get a chance to react with nitric acid, potassium nitrate? No. Then how it will form nitric acid? That's it. For that reason I said that one volatile acid cannot replace another volatile acid, because volatile means it is going to change into gaseous state at a low temperature only. It is going to volatilize at low temperature. So it does not get a chance to react with potassium nitrate. So if it does not get a chance, then how nitric acid will be formed? So hence we prefer concentrated sulfuric acid, which is a non-volatile acid. So hence we prefer this. Alright. So nitric, for the preparation of nitric acid, concentrated sulfuric acid, for that reason is being preferred. Thank you.